Hi, this is Anpichan. Welcome to my mathematics class. Today we will study limits of trigonometric functions. See, uh, it's very easy topic today. I have taken how to find out the limits of trigonometric functions. I have taken few questions, trigonometric functions. Before starting the question, let me remind you the one theorem which one already I have proved in my earlier video. Limit sine of theta over theta as theta tends to 0 is equal to 1, where theta is measured in radian. Okay, already I have proved my earlier video one of the important theorem. Using this theorem we can find out the limits of all these trigonometric functions. So easy, right? That's why what is the important here, this theorem is important. We have to know how to apply this theorem. Importantly, if you know once how to apply, then you can do all these questions, you can crack down without any problem. Okay, let's say how to apply. Okay, here we need the same. If here theta, we need here also theta, and then here also we require theta. Just like, let's suppose, okay, one simple example. Let me take, okay, here sine of any, let me choose, okay, any name, okay, Tina. Let's suppose, okay, here Tina. Then to get, okay, 1, we need also here Tina, and here we need, okay, Tina tends to 0. Tina, and Tina here tends to 0. And one more thing, okay, Tina is in radian. Okay, then we can say this expression gives 1. Then we can say limit of this is 1. Now, okay, now let me tell you in algebraic language. Limit, suppose here sine 2x over, then we need also here 2x, right? And also we need here 2x tends to 0. We can say that is equal to 1. So see here 2x, 2x, alright, same. Okay, these all three things we need, okay, exactly same here. Okay, this tends to 0. Okay, you may say, okay, also sine 2x upon 2x as x tends to 0, even then 1, because, okay, as x tends to 0, 2x also tends to 0. Okay, satisfy the requirement of this, so you can readily write down 1. Okay, so I think you understood how to apply this very important theorem. Now using this theorem, I'm going to tell how to find out the limits of these functions. Okay, let's start. First question, one number. Solution. Question is this one. Limit of tanax over x as x tends to 0 is equal to. Okay, here I have written answer 1. Alright, so it's gonna come, okay, 1. Alright, I'll show you how to get 1. Limit here. Limit x tends to 0. Tan x, we can write down, okay, 10 x we can write down sin x over cos x, and here x. Limit x tends to 0, as x tends to 0, here we can write down the sin of x, x cos x. This will come down. So what is the concept if you are still in confusion? Sin x over cos x, this rational fraction is divided by x. So in another language, we can say sine over x divided by x, symbolical. As you know, in earlier classes, you might have studied here x upon 1. When we convert division sign into multiplication sign, at that time you reciprocal the later term 1 upon x. So it's gonna get, okay, sin x upon x cos x. Using this concept, using this okay, procedure, I have written here sin x over x into cos x. Okay, now next step is as x tends to 0, we can write down the sin x over x into 1 upon cos x, which is also equal to this function. Okay, now as we have studied in limit theorem, if we have a functions a product, then we can write on the separately as taking limit. The same thing, okay, I'm gonna do here. Limit sin x over x into limit x as x tends to 0 1 upon cos x. Okay, so here sin x upon x using this 1 into 1 into 1 over cos x. Cos 0 means 1. Okay, here let me write down the reason here, since limit sin x over x as x tends to 0 1 by theorem, and okay, limit cos x as x tends to 0 is equal to also 1. Already we have approved. I have all these things explained in my earlier video. You can go through that video if you have not still watched. Okay, so your answer is 1. Okay, so we got here limit of tan x over x as x tends to 0 is equal to 1. Now from here one conclusion we got, what's that conclusion? We can use as a formula this limit, therefore limit as x tends to 0 tan x over x is equal to 1. Okay, now as a formula we can use in another question. While solving this, you may use this property while finding the limit of this function, and here also you may use this property. Now two formulas we have generated here. So two formulas. So here mainly one is this one, one is this one, another one is this one, right? So we can use as a formula this property also, this expression also, limit of tan x over x as x tends to 0 is equal to 1. So I think you all understood how to find out the limit of this function. Now I'm going to tell you the second one also. One done by me, and second I'm going to explain. Okay, so I think clear. Now I'm going to expunge all these things from here. Solution of second. Solution. Limit sin of ex of over x as x tends to 0. Okay, here we can't write down 1. If you see here x tends to 0, ax, here is ax, and but here is only x, as I explained just now. Right now I told you we need here same. Here if you are a Tina, then here Tina. If you are Ram, here Ram. Okay, if we have a Sham, and we need here Sham. If you have a David, here also we need David. Okay, so here is just like suppose here Tina, but this is not Tina. This is, let's suppose Rita, and let's make the same. Limit as it stands to 0, we can make here ax. Here also we can make ax. We have multiplied x by a. Now we need to compensate. We can't write down unnecessarily by any number, and you can leave in this position. If you leave as it is formed, then this is not going to be equal this function, which doesn't which is not correct then, and just multiply by a. Okay, now a will be cancelled out, and we will have only sin x upon x. So I think now clear how to make the same. Now is your constant, we can write on the outside of this. Outside we can write down as x tends to 0, sin of ax over ax is equal to. Either you may write down this ax tends to 0 or simply x tends to 0. It doesn't matter. As x tends to 0, ax also tends to 0. Now we can use as a theorem, okay, as a we can apply theorem, okay, according to the theorem, okay, we can write down this one, okay, a into 1, right? What's the reason for this? Because since limit of sine of x, simply sine x also you can say, over x as x tends to 0 is equal to 1, and due to this reason this is 1. So if you have any question, if you think, okay, here ax, here only x tends to 0, but it also becomes, okay, tends to 0. If you multiply both sides, okay, by a, and you're gonna get here, okay, ax tends to 0. So it totally satisfies the theorem. So we can write down 1, okay, no problem. Whether you can write down here or so you may leave it in this position, it doesn't matter, the same thing, okay. So a times 1 is equal to a. So a is the limit of this function. Clear? Now the same type of question you can do. Soccer one question I have left for you for practice. I hope you do. And due to this, okay, let's consider you. I suppose, okay, you do these questions and you get benefits from these doing these questions. And now I'm going to tell you this one, and for number, take one. I will do. I will do this for number. This I will, and same type of question. You will do this, and this one also you can do. If I do this question, same type of question, and then I'll tell you this 7 number. Okay, so so let's find out. 4 number solution. Interesting question. I think you can enjoy by doing this question. If you are new one, if you're old one, okay, you can refresh by this video about the limits of the trigonometric functions. Limit of sine mx upon or over sine of nx, okay, is equal to limit as x tends to 0. We did, okay, here see sine mx, just you can, okay, firstly let's see, okay, sine x over x as x tends to 0 is equal to 1, we can write down, right? If you get, okay, here sine m, so let's try to make this one, okay. So firstly let's make, okay, here mx, no problem, and here is sine of nx. Alright, let's make here, I'm writing here nx, it doesn't matter, okay. And now see xx, they are already, okay, going to be cancelled, and n over m is an extra here. N over n, this number is here in multiplication to this function. So let's make equal whole things equal to this function. Here we need, okay, m upon n. Alright, so mm will cancel and nn cancel. So all are in cancelling positions. Ultimately whole this equal to this. Now we don't have any problem, right? Now we can write down, okay, equal to this, equal to this, okay, is equal to now m upon n, free from x, free from variable. So let's write down, okay, outside, and here limit of x tends to 0. I'm going to do some little bit arrangement here. Mx into 1 upon sine nx over mx. An equation. So it will go up, and the same thing you will get. I think clear. Simple algebra is equal to m upon n times, let's write down separately. Either you may write down it directly, sine mx over mx into or limit as x tends to 0, 1 over sine nx here, nx over nx, alright, is equal to here m over n, right, m over n into limit of this one is 1 by theorem. Here is, okay, 1, limit of 1 is 1, limit of this one is a 1, so 1 over 1. So simply 1 also you may write down is equal to m upon n. M upon n is your limit of function. This so simple, so very simple, we can crack down very easily. Alright, so you can You can crack down this question very easily. There is no problem. Exactly the same method you can apply. Here also same, exactly same, but only instead of m upon n, we have here p and a q. So you can do this also. You can do for practice. Now I'm going to tell you the 7 number. 7 number is little bit different. Okay. Let's say I think this is clear. Now I'm going to tell you the next one. Oh, here we go for 7 number. 7 number solution. So interesting. Limit of trigonometric function. Uh, okay. Limit of sine of x minus a. Here this is a over x square minus a square, and as x tends to a. Listen to me. I forgot to tell you about the form here. You will get to get 0.0 form. This is also in 0.0 form, 0.0 form. All are in indeterminate form. Here also 0.0 form, 0.0 form, 0.0 form, and this is also in 0 form. So okay, let me write down here 0.0 form. So see, okay, if you put a here, if you substitute, okay, here a, then okay, sine of a minus a 0, sine 0 0, and a square minus a square 0. So sine of 0 over 0 means sine 0 over 0. So 0 form. So this means we have to simplify. Okay, let's see. So what we can do here, we need to use a theorem, and let's try to get in theorem from x minus a over here. We can write down x minus a, x plus a. Okay, so I think no problem here. You can understand very easily. Is equal to limit as x tends to a. Now I'm going to do some arrangement here, x minus a, because same, that's why I'm going to keep here and over x plus a like this. Clear? Is equal to limit as x tends to a sine of x minus a over x minus a into limit of x plus a as x tends to a. Okay, so one more step. Yeah, see, listen to me. Okay, if you think, can we write down, okay, one instead of this. Here is x minus a same, but here, okay, according to theory, let's recap. X tends to 0, sine of x is equal to, sorry, 1. I beg to pardon for this mistake here, 1. Now see, x tends to 0. Here is x tends to a. But okay, here x minus a, x, Tina, or Rita. So here Rita, but here no, not that form. Okay, yes, we can write down as x tends to a means x minus a tends to a. If you subtract it from both sides, you can get x minus a tends to 0. Alright, now we can write down, we don't have any problem. Limit as x minus a tends to 0 and sine of x minus a over x minus a. So again I'm going to repeat this line. Okay, 1 upon x plus a. Now everything is in right position. Okay, now we don't have any problem. They are not creating also problem, and this is in theorem form. Now see, x like Rita, and Rita tends to 0. We can write down here 1 and sorry, here into your limit of this as x tends to a. Yeah, already we have done this, and a plus a. Already we have learned how to find out the limit of algebraic functions. Now it's easy. Is equal to 1 upon 2a. So 1 upon 2a is the limit of function. So easy. Alright. Now here also you can do in the same way, right? 8 only 8, okay, 8 number 8 you can. Just let me give you just hint, okay, how can you in shortcut, okay, right? I think now clear. Now I'm going to erase this. You can pause the video to see each and every steps clearly. If you are still not clear, this question just hint. We may write down, okay, like this way: as x tends to p, x square minus p square upon tan of x minus p is equal to limit x tends to p, here x minus p, x plus p over tan of x minus p. This is also in your x, your okay, 0 1 0 form, right? Is equal to a limit as x tends to p, x minus p over tan of x minus p into x plus p. One more bracket I may use here like this way, so that okay, these all things are in one bracket. Limit as x tends to p, we can write down 1 over tan of x minus p over x minus p into x plus p. Okay, now let's separate. Limit of x tends to p, 1 over tan of x minus p over x minus p into limit x tends to p, here x plus p. So simple. So simple steps, okay, you can go through this each and every steps, okay, it's easy. Now here also we can write down the limit x minus p tends to 0, 1 over tan of x minus p over x minus p into limit x tends to p, x plus p. Okay, so yeah, hint, but okay, I will solve this question, no problem. But I have done okay in speed. You can also, now I think you understand these all steps because I have explained this one. Now here we can write on 1. So how what? Because okay, we have proved okay here due to this as x tends to 0, tan x over x is equal to 1. Now look at here is the 1, limit of 1 is 1 and the limit of numerator is 1 and the limit of denominator is 1, using this due to this, okay, right, limit of denominator. And here you are going to get okay as x tends to p, x tends to p plus okay p, x tends to p, right, and here p plus p, and you are going to get here 2p. So 2p is the your limit of this function. So simple, limit of this function. So easy, all right. Now I'm going to tell this one how to. Okay, so you can write down questions, right? Now I'm going to tell you here. Mm, 9 number solution. Well, limit as x tends to 0, sine of ax cos of bx upon sine of cx. And one thing you have to keep in brain, we have to make arrangements to get in formula, get in theorem only for sine, not cos, okay, right? Only we have okay for sine or tan, not for okay cos. And let's make for let's make here uh, theorem, just theorem like form here just okay, very simply you just okay, we need here okay let me write down again, okay, limit sine of x over x here as x tends to 0 is equal to 1, we can write down. So let's try to make okay sine x upon x means sine of reta upon reta. So let's make here, later we'll think okay, so ax upon ax, you just try to complete and later we will think okay how to okay manage, right? And here here cx, so write down here cx over sine cx. Okay, so let's make no problem okay without any tension, you can just write down okay firstly, and here write down okay cos bx, for because we don't have a theorem just like okay this one. Okay, now let's see okay which things are in extra. Sine xx, okay, they can be cancelled, they already are in a cancelled position, and c upon a, because here no c upon a, right? So let's write down, if there are C upon A, let's write down the A upon C. A upon C now. A going to be cancelled and CC going to be cancelled, and XX is also going to be cancelled. Now same we will get, okay, limit of sin x into cos bx over sin cx, okay, same this one. Just we have done, okay, little bit arrangement or simple arrangements, okay, according to this theorem we have used, okay, arrangements. All right, everybody. Okay, so if everything is clear, let's move into the next step. Limit, okay, A upon C, outside we can write down A upon C, P from X, limit x tends to 0. I'm going to write like this way, and Ax into limit x tends to 0, Cx over sin Cx into limit x tends to 0 cos Bx. Alright, and here A upon C, directly we can write down here 1, but one more step I am going to tell you. If you have any confusion, yeah, either, okay, you can leave, okay, in this position, or you can write down, okay, in this way also you can write down, okay, to make it complete theorem, to make it in this form completely, you write down like this way, because x tends to 0. If you multiply by any scalar, that also tends to 0. If you don't write, that is also understood thing. And limit here cx tends to 0, because x tends to 0 means cx tends to 0. Visually 1 over sin cx, this is your sine over cx, because by simple algebra it goes up, and by division into limit cos bx, here bx, okay, as x tends to 0. Alright, now a over c into 1 upon 1, directly simply 1 also you may write down. Limit of 1 is 1, limit of this is also 1. I have shown that thing, right? Okay, and limit of cos bx as x tends to 0, it becomes, okay, cos 0 means 1, okay, and into 1. So finally you have answer A upon C. So A upon C is the limit of this function. Okay, everybody, I think you understood how to find out the limit of trigonometric function. This is the first lecture on trigonometric functions. I'll make, okay, more and more videos on trigonometric function. We have still many things to be done. Okay, so thank you for watching my video, and if you are a newcomer, please subscribe and share. Who are very eagerly waiting for mathematics and searching for this kind of a mathematics, or share for them. Once again, thank you for watching. Don't forget to subscribe if you have not subscribed till now. Okay, so till next video, bye bye.